Perfect. Okay, hello. I'm Frédéric Bosché. I'm from the School of Built Environment here, and research is within the HWU Institute. And I'll talk about dimensional control in the age of BIM. Very quickly, just to review what I will be talking about. Very short couple slides on BIM because, as I expected, Alex did talk about BIM already, so that was very useful. Then I'll talk about the issue of dimensional control, and then talk about laser scanning and building information modeling, and how these two new technologies actually present great opportunities because they are very related in a way. And then I'll talk about what I call scan versus BIM applications, and I'll finish quickly about what's the future work we plan to do in the lab. So very short here, this is coming from the BSI, a report, investors report published in 2009, but I found these actually two sentences are very good definitions of BIM, at least according to me. The first thing is that BIM, as Alex mentioned, is a combination of actually changes in technologies as well as processes, okay? Here, I will actually focus on the technology side of BIM, okay? And from the technology viewpoint, what is important is you have a 3D model, and each component in this 3D model has embedded information. And this information can be just about anything. It can be the product, its placement, material, specifications, fire rating, you name it. You could actually add that information to any of the components and make use of it. So this is a common type of diagram used for BIM. You have kind of the life cycle of the building illustrated here, and different applications of the building information model. At the moment, what you see a lot is most of the efforts in developing and using BIM, they happen here in the design side for creating the volumes and then planning the air conditioning use, the energy use, and so forth. Slowly, we see a lot more usage of building information models within the construction industry, and Alex just showed actually a few of the applications. I'm aware of many more that they have where they make use of the building information models. But interestingly, there is some agreement that most of the potential of building information modeling is here during the operation and the maintenance of the building, during the whole life cycle of the building. And interestingly, this is probably the area where the least advantages have been achieved so far. And one of the reasons to this is the interface between the construction and the operational stage, and how the BIM models are transferred between those different stages. And I'll go back to this in a little bit. So the thing about BIM is that it's supposed to be a WYSIWYG type thing. So WYSIWYG is what you see is what you get. So this would be the BIM model of the corridor before you build it. And on the right is the actual finished corridor. So the thing is, you can have a virtual building before you actually build. You can test it, make sure it's working well, and then once you build it, you should have exactly the same thing. Or should you? This is an example I picked from a presentation from a professor in Salford, who is actually well known in the BIM community, and he uses that figure to illustrate this WYSIWYG aspect. But actually, even within this example, when you look well, you can find like, oh, well, it's not quite true, right? So for example, here, you see the two pipes here. The one starting from the top is in front of the one starting from the bottom, but actually the way it was built was not, it was the opposite. And there were also some valves that were inputted there that do not appear in the model. Okay. Another example is the other pipes here. There is slight differences. And another major one here is that the valves were appearing in the model up there, but actually, when they were built on site, they were built here. Okay? So it's kind of a, I don't know what would be the acronym, but it's what you see is almost what you get, but not quite get. Now I'll talk quickly about dimensional control. Over the years, there has been significant progress in the technologies available to surveyors to control buildings' dimensions during construction, going from the measurement tape, the plumb bobs. Now on the bottom right, you'll have theodolite, and then you have laser-type sensors appearing with a disto, and this is here a total station. So these have improved a lot the way buildings are surveyed during the construction project and controlled. Okay, all the way to now laser scanning. Okay, so these terrestrial laser scanners, this is what they look like. This is one of the latest scanners available. What it does like a total station. It throws a beam of laser, and the beam bounces on the surface of objects around it, and the time it took to come back can be translated into a measurement distance, okay? But this one actually can sweep the whole area very fast and not acquire 1 point, but millions of points in a matter of minutes, okay? And the image here on the right is not very sharp. Actually, there are much better pictures of it, but it's an example of a scan that you get of a room, which probably took a couple of minutes to acquire. And within this scan, you have millions of points that are accurate within, let's say, a few millimeters. Okay, so this is actually a technology that is changing radically the way buildings can be surveyed and controlled. And just the bottom picture here, just to show what's the size of this thing now. It's very small. It can be carried around easily. Really can be used much more widely than it is used now. So I talked about BIM, and I talked about laser scanning. And these two technologies are very related. The reason is because the BIM model gives you 3D information plus all this semantic information you can add to each object. And this, you can see this as the as-designed state of the building. And the laser scanners on the other side can help you acquire the as-built state of the building, okay? And there's thus a very clear link between these two technologies. One important difference is that the BIM model gives you information, but the laser scans you have here, they give you only data. They are just point clouds. So you need to actually process that data to make sense of it. And the way these two technologies are being integrated nowadays is by acquiring a scan from an existing structure and try to recreate a BIM model of it so that it can be used for refurbishment, design for refurbishment or expansions and other applications. Actually, Alex presented the case of the underground utility. They don't use laser scanning for that. They use ground penetrating radar, but they essentially do the same thing. They acquire the existing and they can design around it. And these technologies are called scan to BIM type processes. Take a scan, you try to make a BIM model out of it. Okay, but you can actually look at it in a different way. I think it has been mentioned earlier that the UK government, following the footsteps of Scandinavia, the US, and other big countries, now mandating that BIM models be generated and the BIM concepts be applied to all public projects by 2015, which means by then, if things go as predicted, all buildings will be designed with a BIM model. And so having this BIM model is a great is of great utility to process the laser scan data. And here you can develop new applications that aim to compare what is in the BIM model with the laser scans that tell you what is actually there, okay? And I call these scan versus BIM applications, as opposed to scan to BIM. This is a video that just shows some of the first results that we looked at, that we have obtained using this technology. So here you have a 3D model of a structure. It's a building from Canada, actually. And we overlaid on it the laser scan point cloud that was acquired from the site. And from this, you can easily identify, well, easily is a big word, but you can more easily identify the objects within the model. So here in green, we highlighted these points belong to an object which is next to it. And you can do actually you can get lots of information from this. I just wait a second. Sorry, it's not professional video, but I hope it shows it. Okay, so here, for example, we can illustrate the distances between the points and the model. So we can look at what are the deviations between what was actually built and what we intended to build. And you can also then infer whether objects are there or not there, as is designed in the model, and so forth. What is important to see here is that these points can be directly automatically associated to each individual object. Okay, so this I'll show here. For example, here you have the elevator shaft wall here, and you can see the point cloud has been associated to it, and you can keep a historical record of data acquired, not during construction only, but you could apply this during the whole life cycle and look how the structure is changing, for example, is moving over time. Okay, so these are things we've looked at. Now, what you can do with that information is, which has not been done yet, but there's great opportunities, apply dimensional control procedures that are usually used on site to this data automatically, okay? So for example, we have here inclination data, and it's about looking at the deviation between different stories, how more or less the verticality, the change in verticality over the different stories. We have the object, we know it's a wall. In the BIM model, we can say this is how you control the dimensions of the wall. We have the as-built data, so we can actually automatically apply this procedure to the built data and get that result automatically, as opposed to have a surveyor go on site, acquire individual points, then take his math sheet and look at the inclination results. And you can do that for all the different type of dimensional surveys that needs to be conducted with respect to the specifications. In that case, I took those from the concrete specifications document. Okay, so we've done quite some work, but the idea is now to implement some of those ideas. So for example, I mentioned about integrating the dimensional control procedures within the BIM model, or more or less attaching to each component in the BIM model. How do you control that, at least dimensionally? It's not the only type of control, but it's one of them. For example, you want to control the specifications defined in the National Structural Concrete Specification document. So you can actually digitize those specifications and apply procedures. Just to highlight one thing here, you can apply those procedures as they are done nowadays, okay? But interestingly, laser scanning data provides you a lot more information that the current procedures require. Instead of taking a point every 50 centimeters or every meter, here you have a point acquired every centimeter. So you could actually almost change and improve the way structures are controlled. So I illustrate here, yeah, you could maybe the procedure requires you nowadays to do this, but you could really do that, and you could do even more, okay? So you could improve the results, or the confidence in the results. Other thing we want to look at is take into account color information to support these procedures. At the moment, we look at three-dimensional information only, but laser scanners now give you color. And color information can actually be very useful to look at other specifications and other aspects of the components. Another thing is shape recognition. I'll illustrate what I mean here. What we have found is that from a structural viewpoint, the procedure I showed you works quite well. For example, if you take the top image, you can see in red the point cloud aligned with the model in gray. And that works well for the structural elements. But then when you look at the MEP works, then actually you start seeing a lot more deviations, okay? And maybe in certain cases, okay, that would work. We would be able to recognize the objects the way it is. But then you can actually experience much larger deviations. And for this, we need to develop new techniques to recognize those objects. So there is a lot of work we plan to do in this area. And finally, the last thing I want to talk about is these techniques can actually help delivering true as-built BIM models, or making the process a lot more efficient. What I mentioned earlier in the presentation is that there is a distrust by clients for using the BIM models generated by the designers for their operation and maintenance work. The reason is BIM models are created by the designers, and as we showed here, then they go under construction, and the construction process doesn't quite deliver what is in the BIM model. And therefore, they don't really trust whether they should use that BIM model to do their O&M operations. And so sometimes they just disregard it and do a new model from scratch, for example, using the scan-to-BIM approaches I suggested earlier. But I think that this is way too much of an extreme solution, because our experience is that, and it's illustrated here, yes, the BIM model is not perfect, but actually it's correct in many cases. And by using the approaches like the scan versus BIM approach, you can already very quickly sort out which objects are correct and which ones need to be remodeled. And this can significantly speed up the creation of models that can be trusted and at a much lower cost, because this is typically a very, skillful activity. Okay, that's it with me. Thank you.